Hello everyone, in this video we are going to be talking about how do lithium ion batteries work. And so at the core of all of our lithium ion batteries, we've got three parts. We've got an anode, an electrolyte, as well as a cathode. And so if we zoom in on our anode, what we're going to note is that at the surface of our anode, we've got this graphite surface. And what graphite does is it forms a really nice parking spot, basically where a lithium atom is able to reside. And lithium is a very important atom in this whole process because lithium has a special property in that its outermost valence electron is very loosely held. It wants to get rid of it. And so as we are charging a battery and as the battery becomes fully charged, all of the lithium atoms are going to be sitting very happily inside of all of these graphite parking spots inside of our anode. And so this represents right now a state at which our battery is fully charged. Now, once I've got a fully charged battery, I want to go do something with it, like turn on a light bulb. So what I would do is I would take a wire, and then through this wire I would have my light bulb right here, and I would connect the other side to my cathode, the positive side of the battery. And so what's going to happen is that the electron that's very loosely held by the lithium atom is going to leave. It's going to ionize this lithium. This is now a lithium ion, and its electron is going to move through the copper wire, and then it's going to do its thing, basically make the light turn on. And then the electrons are going to meet up on the side of the cathode. They're going to move onto the positive side of your battery, and that is where we've got a metal oxide present. These metal oxides contain things like cobalt and other metals that are very hard to find, and that leads to a bunch of geopolitical arguments that we're not going to talk about right now. But basically, this is where the electron goes, and the metal oxide, which is this yellow thing, which is inside of our cathode, is what's helping facilitate this process. Now what's going to happen to our lithium ion now that it lost its electron is the lithium ion is going to make its way through our electrolyte. So this paper is the electrolyte, and it's very important to know that only lithium ions can move through the electrolyte. Electrons are not able to. So basically the lithium ion is moving through the electrolyte, and then it will meet up with its electron and the metal oxide, and it basically lives in a very stable state here. So now if we were to zoom out of this process again and look at it, this battery is 50% charged. So half of the lithium atoms that were inside of our anode have been ionized, and its electron has gone to powering our process. Next thing that's going to happen is we're going to continue to discharge our battery, and now that we're at 50% capacity, the other 50% of our lithium atoms are going to also ionize. We're going to take their electrons. That electron is going to move through the copper wire, turn on my light bulb, go to this other side into my cathode, and then meet up with the other metal oxide that's present. And again, we're going to have our lithium ion move through our electrolyte and meet up with its electron that it just lost right there. So now we've got our metal oxide, an electron, and the lithium ion, which is not an ion anymore because now this is a lithium atom that contains a neutral charge being facilitated in this metal oxide environment. So this is the state of a battery that is completely discharged. So right now we've got no lithium at all inside of our anode. I can't get any more power out of this thing, so my light bulb right here isn't turning on anymore. So what's happening next is we're going to want to recharge this battery because we want to turn on a light bulb again. So what happens when we are charging our battery is we're going to take some other power source, and basically we're going to create a potential at which the electrons inside of our cathode will want to move back into these anodes, and specifically these graphite parking spots available to them. So once I am charging my battery, if I were to plug my iPhone into the wall, what's happening is that this electron is going to move through the wire and then back into the parking spot that the graphite has created for it inside of our anode. Now, because our lithium ion is going to want to be back with its electron, because now this has a negative charge, these lithium ions are going to just move back through the electrolyte and into these parking spots in the graphite to meet back up with their electrons. So right now, if we're to zoom out, this battery is 50% charged. So as we continue to charge it, the next electron is going to leave its lithium atom. It's going to ionize this lithium. We're going to get a lithium ion that's positively charged, and this negatively charged electron is going to move through our wire, and then it's going to go back into its graphite parking spot. And again, the lithium ion is going to move through the electrolyte and into the graphite parking spot to be back with the rest of the electron that it lost. So basically, right now, if we zoom back out of this process, we're back at 100% charged. And so the important things to take away here are that the anode is where we're basically parking our lithium atoms in the fully charged state. And then the cathode is where you park your lithium atoms in the fully discharged state. And then as you're charging it, you're basically moving your lithium ions from your cathode into your anode. And then when you're discharging it, you're doing the opposite of this process. And it's actually what's resulting in the ability to have a light bulb turn on or power some transistor or do whatever you want inside of your phone or your laptop. So that is what's going on here. The thing that you see a lot of on the news is like, these batteries blow up, they make fires. And the question is, what happens in these scenarios? So in these scenarios, if we were to take a look at our electrolyte, what happens is if I got a fully charged battery here, or I had a fully discharged battery, is if my electrolyte were to disappear, and if I just took this whole thing away, now I have nothing inhibiting the movement of these lithium atoms into these metal oxides, and lithium is a atom that loves being with these metal oxides. So basically what happens is that immediately all of these lithium atoms are moving into these metal oxides in your cathode, and that results in a huge release of energy, because this is a much more stable state than being in these graphite parking spots. And this results in releasing a bunch of energy very, very quickly, which results in people's batteries blowing up and a bunch of explosions. So that is what happens in those cases. What we do to protect those things, we've got some kind of like separator device. We have additional layers to basically prevent the electrons from being able to flow through our electrolytes when our electrolytes go away. But that is what happens in those very bad cases where we get, phones blowing up on airplanes. So that is going to wrap things up for this video. Hope it helps. Let me know if you guys have any questions, and thank you all for watching.